Hello, dear students. Today we're going to review the fifth practical work of the discipline, Hygienic Certification of Workplaces. This discipline is for students of the educational program 6B 11201, Life Safety and Environmental Protection. The topic of the work is called Determination of the concentration of harmful substances in the air of the working area. This presentation was prepared by Assistant of Mine Aerology and Labor Protection Department, Isakov Bekjan Yerbulatovich. The purpose of the work: training in practical skills for determining the concentration of harmful substances in the air of the working area. Lessons plan. First, introduction to the theoretical part of the material. Second, the procedure for performing the work. And third, task for practical work. Let's begin with the main idea of this work. The clean lines of the air environment is characterized by the presence of harmful substance in it. So, harmful substance is a substance which, upon contact with the human body in the event of a security breach, can cause disease or decline in health status. Discover contemporary methods in the process of contact with him, and at the remote periods of life present and future generations. Human exposure to chemicals can manifest itself in the risk of immediate effects, for example, acute intoxication, risk of long-term consequences, for example, oncology, immune disorders, etc., and risk of chronic specific intoxication and non-specific pathology. To assess the risk of immediate effects, a methodology has been developed based on a model of individual thresholds. This technique includes two steps. The first is based on epidemiological data on the degree of health disorders under certain dose-time conditions. And the second step is based on the use of information about the values of threshold concentrations, which are determined in the course of experimental studies. Priority approaches to assessing the health risk of workplace air pollution are risk assessment by direct transfer of experimental data of toxicological experiments to the production conditions, taking into account the coefficients of species and sex sensitivity. Assessment of the risk of diseases based on the empirical integral function of the distribution of patients, using data from medical statistics for specific industries. In practice, the assessment of working conditions is made under the influence of the following factors. The first factor, chemical factor. Second factor, factors of biological nature. Aerosols of predominantly fibrogenic action. Aeroionizations. If it's not possible to use this approach, the risk assessment is carried out in a calculated way using the equations of individual thresholds. MPC. What does it mean? Maximum permissible concentration. Maximum permissible concentration of harmful substances in the air of working zone. Focus, which during the working time, daily, except weekends, work for 8 hours or other duration, but not more than 41 hours per week, may not cause diseases or deviations in health status. Discover modern methods of research in the process, or in a separate terms of life of present and future generations. The hazard class of the substance, according to the degree of exposure, is determined by the MAC values and toximetric characteristics. The assessment of working conditions, depending on the content of harmful substances in the air of the working area, is based on a comparison of the maximum, or if there is an appropriate standard, the average concentration of harmful substance with their maximum permissible concentration. In this case, substances that are dangerous for the development of acute poisoning with an acute mechanism of action, irritating action, allergens, carcinogens, anti-tumor drugs, hormones, estrogens, narcotic analgesics, and substances of first, second, and third, fourth hazard classes that are not listed above are allocated to separate groups. The group of substances dangerous for the development of acute poisoning includes acids, alkalis, chlorine, fluorine, sulfur, nitrogen containing compounds as phosgene, sulfur oxides, nitrogen, bromide, chloride, hydrogen cyanide, hydrogen fluoride, etc. First of all, they cause an inflammatory reaction in which the respiratory organs, skin, and mucous membranes of the eyes are affected. Allergens are some nickel compounds, pyridine derivatives, alkaloids, aminoplasts, chlorophos, some organic acids, synthetic detergents, tobacco, phenylformaldehyde resins, chromium, compounds, zirconium, epoxy resins, etc. Allergens cause changes in the body's reactivity, leading to different types of allergic reactions. Carcinogens cause the formation of malignant tumors. These include polycyclic aromatic hydrocarbons, which are part of oil, coal tar, and pitch, formed during the thermal processing of fossil fuels at a temperature of more than 3,500 degrees. Aromatic amines, products of aniline paint industry. Benadryl, asbestos, dust, benzene, beryllium, and its compounds, chromates, arsenic compounds, nickel, soot, etc. Anti-tumor drugs, hormones, estrogens, and narcotic analgesics, such as narcotin, codeine, morphine, thebaine, promedol, etc., are substances of the first hazard class, for which inhalation and skin contact should be excluded. When working with this substance, regardless of their concentration in the air of the working area, working conditions are classified as the second degree of harm for analgesics and the fourth degree of harm for anti-tumor agents of the third class. For substances whose maximum permissible concentration is represented by a single maximum value, the average exchange concentration is determined, with the exception of irritating substances and substances with an acutely directed mechanism of action. And the values of the actual maximum and average exchange concentrations of substance in the working area are compared with the established maximum permissible concentration for them. If several harmful substances of unidirectional action with summation effect are simultaneously present in the air of the working area, the result of their action is estimated by the sum of the ratio of the actual concentrations of each of them to their maximum permissible concentration. Acceptable working conditions include a situation in which this amount doesn't exceed 1. In this formula, C is the actual concentration of the first substance. When several harmful substances that do not have a unidirectional effect are simultaneously contained in the air of the working area, the maximum permissible concentration remains the same as for an isolated action. The assessment of working conditions is carried out as follows. For a substance whose concentration corresponds to the highest class and degree of harm. Second, the presence of any number of substances of class 3.1 doesn't increase the degree of harmfulness of working conditions. 3 or more substances of class 3.2 translate working conditions into the following degree of harm 3.3. And the last one, 2 or more harmful substances of class 3.3 transfer working conditions to class 3.4. Similarly, the transfer from class 3.4 to class 4 of dangerous working conditions is carried out. If one substance has several specific effects, allergen or substance with an acute mechanism of action, the assessment of working conditions is carried out on a higher degree of harm. So, maintaining the necessary chemical composition of the working area, air in production facilities for storage, maintenance of machines is important for the health, normal well-being, and working capacity of workers. We all know the chemically pure air that contains nitrogen 78%, oxygen 20%, argon 0.23%, carbon dioxide 0.03%, and other gases 0.01%. However, in production conditions, the specified air composition will change significantly as a result of various harmful substances entering it. Many production processes for the maintenance and repair of cars and tractors are accompanied by the release of various harmful gases and vapors, into the atmosphere of the working area, which, penetrating in the human body, cause painful phenomena in it. The air environment of working premises can be significantly polluted by exhaust gas of machines containing harmful impurities, carbon monoxide, nitrogen oxides, aldehydes, carbon dioxide, sulfur dioxide, etc., as well as harmful emissions during the production of various working. Poisoning with harmful gases and vapors can be acute and chronic. Acute poisoning occurs when large doses of toxic substances suddenly enter the body and is characterized by rapid signs of the disease. Chronic poisoning develops gradually due to long-term and constant exposure to small doses of toxic substances, and is characterized by the persistence of caused changes in the body. The main causes of industrial poisoning can be violation of safety rules and industrial sanitation, the use of equipment and technological processes that are not perfect from the point of view of occupational health, insufficient ventilation of industrial premises, improper organization of the use of personal protective equipment, and etc. The composition of the air in working rooms must be constantly monitored, preventing the increase in the established maximum permissible concentration of harmful substances. To control the level of air pollution with harmful gases and vapors, an express method is used using special indicator tubes and gas analysis devices. The simplest and most common are portable chemical gas analyzers of the types GH and UG2. Procedure for performing the work. Number 1. Separate into separate groups substances that are dangerous for the development of acute poisoning with an acute mechanism of action, irritating action, allergens, carcinogens, anti-tumor drugs, hormones, narcotic analgesics, and substances of hazard classes 1, 2, and 3, 4 that are not listed above. Compare the maximum, or if there is an appropriate standard, the average daily concentration of harmful substances with their maximum permissible concentration using the table below. Task for practical work. To perform gas measurement using the GH gas analyzer directly at the workplace, you must break off both ends of the indicator tube in the aspirator eye, then suck air through the tube. To do this, take the aspirator in your hand, squeeze the fur until it stops. Insert the tube into the mouthpiece of the aspirator with the direction of the arrow on it towards the aspirator, and then release the fur until it's fully opened. After one stroke of the bellows, look at the indicator tube. If the color of the powder reaches the least division on the tube or exceeds it, the measurement should be stopped and immediately leave the room, since the concentration of gas or stream in this case exceeds the maximum permissible concentration. If after one move of the fur color doesn't appear, the measurement continues and makes 9 more moves of the fur, 10 in total. At the same time, you need to monitor the color of the tube. If there is a threat of overshooting it, you need to stop sucking air and remember the number of moves of the fur. Then, the gas concentration value is determined using the scales available on the tube packaging. This indicator tube is applied to the scale, combined ring the tube with the scale division, and the length of the painted portion of the tube is determined by the scale of the concentration of harmful substances. If several moves of the fur aspirator are made during the measurement, The concentration of gas or stream is determined by the formula, which you can see here in this formula. K is the scale reading, and M the number of moles of the milk. Here you can see 12 control questions. Let me read you some of them. For example, question number 1. Under what conditions do acute and chronic poisoning occur? Question number 2. How is air sucked through the GH tube? And question number 3. What is the principle of operation of the GH gas analyzer? To answer this question, you can use this recommended literature. So, thank you for your time. Thank you for listening. Goodbye.